Section 7.1 Day 3, Line tangent to a parabola. A line L that is tangent to a parabola at a point P forms an isosceles triangle such that the segment from P to the focus forms one leg of the triangle. The segment along the axis of symmetry from the focus to another point on the tangent line forms the other leg. If you find the distance from F to P and then go the same distance from F through the vertex to another point, these 2 points are on the tangent line to the parabola at the point P. So in other words, we're trying to find the equation of this line that touches the parabola in this spot only. Write an equation for the line tangent to y equals x squared minus 2 at 2, 2. If we add 2 over, we get y plus 2 is equal to x squared. So the vertex is 0, negative 2 down here. Then we see that the 4p is in front of the variable that's not being squared, and it's 1. 4p is equal to 1, so p is equal to 1/4. First of all, p is positive, and since x is being squared, this parabola opens up. And it only opens up, the focus is only 1/4 above the vertex. Now we're also looking at a point 2, 2, and the parabola goes through the point 2, 2. So there's another point on the other side that is symmetric, and we want the point down here to connect these 2 points for the tangent line. So the first thing we need to do is find the distance from this focus to the point 2, 2. Well, that focus point is the point 0, negative 1.75, because we're 0.25 up from the vertex, so we're 0.75 down from negative 1. We're trying to find the distance from the focus to the point 2, 2. And the distance formula is the Pythagorean theorem. We have 2 minus 0 squared plus 2 minus negative 1.75 squared, which is equal to the square root of 4 plus 3.75 squared. And when we work this out on a calculator, we get 4.25. Now what we found is the distance from the focus to a point on the parabola is 4.25 units away. Well, now we have to go 4.25 units from the focus through the vertex to find the other point that's on the tangent line. Well, if we go 0.25 down, we get to this point, we get to the vertex, and then from the vertex we'll have to go 4 more. 1, 2, 3, 4. Well, now we have the point 0, 1, 2, 3, 4, 5, 6, 0, negative 6, and we have the point 2, 2. Those 2 points are sitting on the tangent line. Now we just have to come up with the equation of this tangent line. Let's get the slope. We have 2 minus negative 6 over 2 minus 0. That's 8 over 2, so the slope is 4. We have y equals, actually let's not do y equals. We have y minus 2 is equal to 4 times x minus 2. Y minus 2 equals 4x minus 8. Y is equal to 4x and then minus 6. Let's show on the calculator that this is actually working. Let's go back up to the equation x squared minus 2, and let's make this one a little darker. This is going to be the tangent line, and we found out that's the line 4x minus 6. 4x minus 6. Let's graph both of these on the standard window. There's the parabola, and here comes a tangent line, and that tangent line touches right at 2, 2, and that's it. So it touches, and that's it. That's a tangent line. Write an equation for the line tangent to y squared equals 4x plus 4 at 0, 2. Well, we have the parabola y squared is equal to 4 times x plus 1. The vertex is negative 1, 0. So negative 1, 0 right there. This parabola opens to the right or the left, and since p is positive, it opens to the right. 4p is equal to 4. That makes p equal to 1. So that puts us right back at 0, 0. Now the point that they give us on the parabola is 0, 2. Now we just need to find the distance from 0, 0 to 0, 2. I don't really need the Pythagorean theorem to do that. I don't need the distance formula. That's 2 units away. Since from the focus to the point it's 2 units away, we're going to go 2 units from the focus through the vertex. And that puts us right here at negative 2, 0. We have the points negative 2, 0 on the tangent line, because here's the parabola. There's the tangent line. We have negative 2, 0 on the tangent line, and we have 0, 2 on the tangent line. Let's get the slope. The slope is 2 minus 0 over 0 minus negative 2. That's 2 over 2, so the slope is 1. We have y minus 2 is equal to 1 times x minus 0. We have y equals x plus 2. The answer is letter C. Write an equation for the line tangent to this parabola at the point 1, 6. Let's minus 2 over and get it set up to complete the square. We have x squared plus 3x plus something. If we take 3 divided by 2, we get 3 halves. And then when we square that, we get 9 fourths. We need to add 9 fourths to both sides. Negative 2 is negative 8 fourths, and we're adding on 9 fourths. That gives us y plus 1 fourth is equal to, we have, this factors into x plus 3 halves, x plus 3 halves. We have x plus 3 halves squared. The vertex is negative 3 halves and negative 1 fourth. We have negative 1.5, negative 1 fourth. That's about right there. The 4p in this problem, that's always in front of the variable not being squared, is equal to 1. So p is equal to 1. Now this parabola opens up because p is positive and x is being squared. So that puts us right on the x-axis for the focus. This parabola is going through the point 1, 6. 1, 1, 2, 3, 4, 5, 6. Right there. And we have the parabola. Now we're looking for the tangent line to the point 1, 6. We need to find the distance from the focus to the point 1, 6. Well, the focus is negative 1.5 or negative 3 halves, comma 0, and we're going through the point 1, 6. We're going to need the distance formula here. We have 6 minus 0 squared plus 1 minus negative 1.5 squared. We're going to use our calculator to get that decimal value. So the distance is 6.5. So the distance from the focus to the point on the parabola is 6.5 units. Now we're going to have to go through the vertex down 6.5 units. 1, 2, 3, 4, 5, 6.5. That puts us right here. Now we can find the equation of the tangent line. We know we're going through the point 1, 6. The other point that is on the tangent line is negative 3 halves, comma, negative 6.5. Let's see, negative 6.5, that's negative 13 halves. We have m equals negative 13 halves minus 6 over negative 3 halves minus 1. And we can multiply everybody by 2 here. Negative 13 minus 12 over negative 3 minus 2. We have negative 25 over negative 5, so the slope turns out to be 5. We have y minus 6 is equal to 5 times x minus 1. Y minus 6 equals 5x minus 5. We have y equals 5x plus 1. Write the equation of the parabola in standard form. Identify the vertex, focus, axis of symmetry, and directrix. Then graph the parabola. First thing we have to do on this one is divide everybody by 3. We have y squared plus 2y plus 5 is equal to 4x. Now we're going to minus 5. And we'll set this up to complete the square. We have 4x minus 5 and then plus something. 2 divided by 2 is 1. 1 squared is 1. We need to add 1 to both sides. We have y plus 1 squared on the left side and 4x minus 4 on the other. To finish this, so we get in the proper form, we need to factor out a 4. The vertex is 1, negative 1. We have 1, negative 1. 4p is equal to 4. That makes p equal to 1. y is being squared, so we're going to go to the right one. There's the focus, which is 2, -1. Focus is 2, -1. We have the vertex, the focus, axis of symmetry is y equals -1. Axis of symmetry, y equals -1. And the directrix, well, the directrix is going to be 1 to the left of the vertex. That's going to be the y-axis. So the directrix is x equals 0. Now we just have to find the locus rectum is actually the absolute value of 4p, and 4p is sitting right there. That's equal to 4. We have to go 2 units up and 2 units down to get a couple more points on the parabola. I missed there a little bit. There we go, that's better. Write the equation of the parabola in standard form, identify the vertex, focus, axis of symmetry, and directrix, then graph the parabola. Let's go with x squared is equal to, we don't need plus, is equal to 4y plus 4. So we get the variables on opposite sides, and we have x squared is equal to 4 times y plus 1. The vertex is -1, 0, so we have -1, 0. 4p is equal to 4 again, so we have p equals 1. X is being squared, so now that's 1 up. The focus is -1, 1. Focus, -1, 1. We need the axis of symmetry. Axis of symmetry is x equals -1. The directrix is 1 down. Actually, I don't know why I'm dotting that. I can just draw it solid. 1 down from the vertex, so we have that's equal to y equals -1, and then graph the parabola. We have the absolute value of 4p is actually equal to 4, so we're going right and left through the focus 2 units. And there's the parabola.